Welcome to the next session of General Organic Chemistry. In this session, we will go through hybridization. Hybridization, I have already given you the concept of hybridization and chemical bonding. There I have given you concept of hybridization, how to find out the hybridization of organic molecules as well as other molecules. But I have given you certain formulas, 4 or 5 formulas, steric number, how to calculate sigma and pi bonds, right? What was the need of hybridization? Here in organic chemistry, I will repeat one formula and I will give you basic concept about hybridization so that it can be utilized in this organic portion also. What is hybridization? What is the definition of hybridization? If you have to, what is hybridization? I can say hybridization is a thought process. It has no practical proof. It is the thought process which we use to provide a scientific proof to give the shape of a molecule. But hybridization is a thought process which we use to provide a scientific proof to find out the shape of a molecule. I can say like this. Basically, hybridization is not the real factor which explains shape, it is energy. Every molecule attains that geometrical shape in which it has minimum energy and maximum stability. If I will take example, this example, first example is H2O. I take one more example, CH4, NH3 and H2. Correct? What is the hybridization of methane? Go through steric number. Steric number is equal to number of sigma bonds plus number of lone pairs. Gives the hybridization. How many sigma bonds are present? 4. Lone pair 0. It is 4. Hybridization is sp3. Clear? Right? When steric number is 4, it is 1s and 3p. What is the hybridization of ammonia? Nitrogen. It has 1 lone pair. Right? So it is steric number will be equal to sigma bonds are 3. Lone pair is 1. 3 plus 1 is 4. It is hybridization is also sp. What in case of water? Oxygen have 2 lone pair, right? What is the steric number? Steric number is sigma bond 2, lone pair 2, 2 plus 2 is 4. That means hybridization is again sp3. What is the shape of CH4? Is it tetrahedral? What is the shape of NH3? It is a trigonal pyramidal. What is the shape of water? Is it bent? Or V or angular? Right? So I will again tell you the hybridization. Basically, what hybridization is a thought process which we use to provide a scientific proof in order to find the shape of a molecule. Basically, hybridization does not explain the shape of molecule, it is energy which explains the shape of molecule. And every molecule attains that geometrical shape which has minimum energy and maximum stability. तो क्या मैंने बताया हाइब्रिडाइजेशन एक थॉट प्रोसेस है जिसको हम इस्तेमाल करते हैं ताकि हम साइंटिफिक प्रूफ प्रोवाइड करें मॉलिक्यूल की शेप के लिए. मॉलिक्यूल की शेप एक्चुअल में हाइब्रिडाइजेशन नहीं बताती, ये कौन बताता है? एनर्जी बताती है. और हर एक मॉलिक्यूल वो ज्योमेट्रिकल शेप अटेन कर रहा है जिसमें इसकी एनर्जी कम हो और स्टेबिलिटी ज्यादा हो. देखिए अगर हाइब्रिडेशन की बात करें, सेम हाइब्रिडेशन sp3 अगर यही रियल फैक्टर होता तो देयर शेप वुड हैव बीन सेम बट दे हैव डिफरेंट शेप. बेसिकली इट्स द एनर्जी. In chemical bonding we have gone through shape of molecule as well as Weisbach theory, right? Lone pair is not a part of geometry, right? So please write it down. Hybridization is a thought process. Hybridization is a thought process which we use to provide a scientific proof for explaining shape of molecules. Next point. Hybridization is not the real factor hybridization is not the real factor which is responsible for shape, but it is energy. But it is energy. Next point. Every molecule attains that geometrical shape. Every molecule attains that geometrical shape in which it develops minimum energy. Write it just like this. In which it possesses minimum energy and maximum stability. Let me explain this again. Hybridization of methane molecule, ammonia and water by steric number, which I have explained in chemical bonding. Steric number equal to number of sigma bond pair plus lone pair. We have only sigma bond pair. Carbon does not possess lone pair. 4 plus 0, 4 sp3. It is tetrahedral. It is 3 bond pair, 1 lone pair, 4 sp3 trigonal pyramidal. It is 2 lone sigma bond pair and 2 lone pair, 4 hydrogen sp3, and it has bent VR angular shape. Clear? I don't have go to the shape because I have explained it in chemical bonding. Now I will give you one more formula how to find out the hybridization of organic molecules. You can also find out hybridization by simply counting sigma and pi bonds. Right? I will give you a formula which you remember. Right? I have also explained it when I mentioned about that table. In case of sp3 hybridization, if the molecule have 4 bond pair, 0 lone pair, it is tetrahedral. 4 bond pair, 1 lone pair, TP, trigonal pyramidal. 3 bond pair, 1 lone pair. फिर 2 bond pair, 2 lone pair, bent or V shape. 1 bond pair, 3 lone pair, it is linear. I have explained this formula for sp2, sp3, sp3d2, sp3d, sp3d2 and d. Right? d3. I have mentioned this. Now I will give you the formula which you have to use, apply to find out the hybridization of organic molecules, which we will be using in this portion, in organic portion. Right? It is in first column. It's the structure. Second column will be number of sigma bonds. Number of pi bonds. Number of pi bonds. Hybridization. Bond angle. And next is shape. Next point is that in organic compounds. What are organic compounds? In first lecture I have mentioned it. What are organic compounds? Hydrocarbon and their derivative are organic compounds. What is hydrocarbon? Any compound which is composed of carbon and hydrogen. Leave aside. Main backbone is carbon. Does carbon possess any d orbital, empty d orbital? No. Why? What is the atomic number of carbon? What is the electronic configuration? 1s2, 2s2, 2p2, 2. 2d does not exist. D comes in third shell, right? So in organic compounds we have to deal with sp, sp2, sp3 hybridization only, but not with sp3d, sp3d2, sp3d3. Why? Because carbon does not possess empty d orbital. Clear? So we have to mention only how many pairs of it is 3. Let me take the first structure. How many sigma bonds does this molecule possess? All the bonds are sigma bonds. So it has 4 sigma. It has 0 pi. Steric number is 4 plus 0. It is 4. Hybridization is sp3. Right? Its bond angle is 109 degree 20 minutes. Right? Yes. And hybridization shape is tetrahedral. Clear? Now I will take the second structure. If I will take carbon atom, it contains 1 pi bond. How many sigma bonds? 3. 1, 2, 3 and 4. Because carbon is tetravalent. It has valency 4. It has 1 pi bond, 3 sigma bonds. So number of sigma bonds are 3, number of pi bonds are 1. Its hybridization is sp2. Because sigma bonds take part in hybridization, not pi bond. When 1 pi bond is present, hybridization is sp2. What's the bond angle? 120. What is shape? Trigonal, planar. I already have mentioned it in chemical bond. I am repeating this, right? If I will keep one triple number, 1, 2, 3 and 1, how many sigma are now present? 2 sigma, 2 pi. What will be the hybridization? It is sp. What's the bond angle? 180 degree. What is shape? It is linear. Or I can write this compound also. Or this compound can be just like this, double bond on both sides. It has 2 sigma, 2 pi. Same case. It has 2 sigma, 2 pi. Hybridization same, bond angle same, structure is same. Mention, keep this table in your mind, and I will be applying in questions and we will apply this formula. Note it. अब मैं प्रैक्टिस के लिए कुछ क्वेश्चन देता हूँ. Explain hybridization of each and every carbon atom. Can you mention hybridization of each and every carbon? Simple point. If carbon atom contains only sigma bonds, it always has sp3 hybridization. Am I right? So can I say all carbon in this example possess sigma bonds only? There is no pi bond. When there is no pi bond, all carbons are sp3 hybridized. First point is all carbons are sp3 hybridized. Is first point. If I will take this compound, what is the hybridization of this carbon? Only sigma bonds. Let me know. It is sp3. What is the hybridization of this carbon? Only 1 pi bond. Presence of 1 pi bond. It is sp2. 1 pi sp2 and it is sp3. Clear? If I will take compound this CH3 CH double bond C CH3 CH2 CH3. Mention hybridization. All sigma sp3 1 pi sp2 1 pi sp2 all sigma sp3 all sigma sp3 and it is sp3 hybridized. Can you mention the hybridization of this one? I will give you a few more examples. What is the hybridization of this? Start from this carbon. sp3 right. This one sp 2 pi bonds right. It is sp 2 pi bonds. It is sp. How many pi? sp2 1 sp2 1 pi. It is sp2. If I will take a compound just like this ch3 ch double bond c double bond c double bond ch2. What is the hybridization of this carbon? sp3. It is sp3. This one sp2. sp2. This one sp2. It is sp. 2 pi. One on this side, one on this side. It is sp. What about this carbon? sp again. What about this carbon? sp2. Write it down. Be quick. Let me take few more examples. Now we will be doing the hybridization of those compounds which contain charge, positive as well as negative charge. I will mention all examples. What is the hybridization of this compound? All sigma bonds. How many sigma bonds? 4. Right? 3 sigma bonds with 3 hydrogen, 1 with carbon, it is sp3. This carbon, 2 sigma with 2 hydrogen, 2 sigma with other 2 carbon, it is sp3. What is the hybridization of this carbon? It has only 3 sigma, not 4. Because 4th sigma bond is last time it has developed a positive charge. It is sp2 hybridized. Right? I will take one more example. If I will take compound just like this, CH3, CH2, CH2, and I will take a negative charge here. What's the hybridization? Is it sp3?
sp3.
It is sp3. What about the hybridization of this molecule? Let me know hybridization of this. By sp3. How many sigma bonds does it possess? How many sigma bonds are present? 3.
And one is
Negative charge is equivalent to lone pair. It has bond pair, sigma bond pair 3. Negative charge equal to lone pair 1. 3 plus 1 is 4. Its hybridization is sp3. Clear? I will take an example like this. Say CH2 double bond CH, single bond CH2, single bond CH, double bond CH. It contains positive charge. What is the hydrogen of this carbon? 1 pi bond, it is sp2. 1 pi bond, is it sp2? All sigma, is it sp3? 1 pi bond sp2. What about the hybridization of this carbon? How many sigma are present? Only 2 sigma. 1 pi and 1 empty orbital containing positive charge. Its hybridization is sp. Clear?
Yes, sir.
Let me give one more example, then you can write down. I will mention a few more examples. Suppose if I will take the compound just like this, CH2 double bond CH, single bond CH2, and it contains negative charge. What is the hybridization of this compound?
sp2.
sp2. Clear? It is sp2. What is the hybridization of this compound?
sp2.
sp2. What is the hybridization of this compound? It should have been sp3. Why? Because it contains bond pair 3, lone pair 1. But this negative charge is involved in resonance. It undergoes resonance, delocalization. I can say whenever any lone pair or negative charge is adjacent, it is in conjugation with double bond, it shows resonance, and due to resonance it is sp2 hybridized. I will show you why. We have to go to resonance and GOC. So its next R will be just like this. This will be just like this. CH2 negative, single bond CH, double bond CH. शॉर्ट में आपने ये थे अपना अगर नेगेटिव चार्ज पहला पड़ोसी होगा डबल बॉन्ड का, रेजोनेंस होगा, रेजोनेंस की वजह से हाइब्रिडाइजेशन. अब देखो इसकी क्या है, इज इट sp2? इट इज द फर्स्ट पड़ोसी ऑफ दिस, इट इज आल्सो sp2. इट इज आल्सो sp2. क्लियर? क्लियर? सो write it in note it down. I will let you write it down. Negative charge oblique lone pair, negative charge oblique lone pair present at neighboring position of double bond, present at neighboring position of double bond and involved in resonance, oblique delocalization or conjugation, involved in resonance, delocalization or conjugation is not considered in hybridization. Is not considered in hybridization. What does it mean? That means if you have to remove this, how many sigma bonds are now present? Only 3. It is sp2. It is not considered in hybridization because it undergoes resonance, and due to resonance it develops PDCH. What is PDCH? It is partial double bond character. Partial double bond character. I have mentioned this in chemical bonding, right? Noted. Now we will do exercise on this, right? Structure. In next column, number of sigma bonds. Next column, number of pi bonds. And next, number of sigma bonds between sp2 hybridized carbon atom. राइट मैंने यहाँ सिंपल स्ट्रक्चर देखना, आपने उसमें गिनने सिग्मा बॉन्ड कितने, पाई बॉन्ड कितने और सिग्मा बॉन्ड sp2 के बीच में कितने. What? I will give you simple structure of organic molecule. You have to find out how many sigma bonds it contain, how many pi bonds it contain, and the number of sigma bonds between sp2 hybridized carbon atoms. Let me take an example of this. First example is it ethane, right? How many carbon atoms are present? 1, 2. That's F. It contains double bond E. It is ethane, right? How many sigma bonds are present? It is in BLN form. If you write it in which form?
1.
Is it diffused or expanded structural formula? Now calculate sigma bonds. How many sigma bonds are present? 1, 2, 3, 4 and 5. Sigma bonds are 5. How many pi bonds are present? Only one? 1. How many sigma bonds are present between sp2? This carbon contains pi bond, it is sp2 and it is also sp2. Between sp2 there is only one sigma and it has one sigma bond. समझ आया? दोबारा बता दो. देखिए ईथीन मैंने दिया, BLN में दिया. अगर आपको इसमें दिक्कत होती है तो ये बना लो, है ना. यहाँ दिक्कत वैसे होनी नहीं चाहिए. क्यों? कार्बन टेट्रावैलेंट है, इसकी वैलेंसी 4 है. जब वैलेंसी 4 है तो कार्बन क्या कर रहा है? कार्बन के यहाँ एक बॉन्ड, ये एक बॉन्ड दो सेट्स पे 2 बचे तो वो 2 सिग्मा. या इसमें पहले कन्वर्ट करो जब तक एक्सपोर्ट हो जाओगे. when you will do enough practice then you can find sigma and pi bonds in BLN also, right? So how many sigma? That is carbon double bond. Carbon is tetravalent. Carbon has valency of 4. 2 are satisfied, 2 unoccupied. Put 2 hydrogens. Right? How many sigma? 1, 2, 3, 4, 5. How many pi? 1. Number of sigma between sp2 that is only 1. Between sp2. Clear? Out of 5 sigma bonds, how many sigma bonds are carbon hydrogen? How many sigma are carbon hydrogen? 4. Carbon sigma? 1. Clear? Let me take one more example. How many sigma bonds are present? Can you calculate by BLN? Carbon first, carbon second, it is sp2, it is sp2, it is sp2, it is sp2. I have mentioned only sp2 but not sp3. Why? Because I have to find out sigma bonds between sp2. Okay? First of all, how many sigma are present? This carbon is tetravalent, 1 valency satisfied. How many hydrogen does it have? 3. It has 3 hydrogen atoms. This carbon is tetravalent, 1, 2, 3. It will contain 1 hydrogen. This carbon is tetravalent, 1, 2, 3. 3 satisfied. It has 1 hydrogen. I will mention this number in only number of hydrogens. How many hydrogen will be present here? 1, 2, 3. That's 1. How many hydrogens here? 1, 2, 2. First point clear. Second point is calculate total number of sigma. 3 plus 1 4 plus 1 5 plus 1 6 6 plus 2 8 9 10 11 12. You got it? There are 12 sigma. Out of 12 sigma, how many are? 1 2 3 4. 4 are carbon sigma, and out of 12 8 are carbon hydrogen sigma. Got it? I can put this compound like this in CSF form. यहाँ पे कार्बन है, ये CH है, डबल बॉन्ड के साथ किसके साथ बनाएगा? CH के साथ. यहाँ आएगा CH3. क्लियर? CH3 CH 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 1 2 3 1 2 3 4 5 1 2 3 4 5 यही कंपाउंड है। गिनो सिग्मा 3 हाइड्रोजन के हुए यहाँ गिनो 1 मिनट 3 4 5 6 7 8 9 10 11 12 how many pi 1 2 1 2 pi are only 2 how many sigma between sp2 sp2 is it sp2 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 between sp2 sp2 that is the 1 2 3 they are only 3 you got it
Yes, sir.
write it down I will mention few more examples find sigma pi and sigma between sp2 sp2 in this molecule let me know in this compound how many sigma are present mention a simple way to find out sigma is that every carbon it has 6 carbon atoms right and every carbon is tetravalent carbon is tetravalent it has a valency of 4 2 are satisfied that means it will contain 2 hydrogens 1 2 3 it will contain 1 hydrogen 1 2 3 1 hydrogen 1 2 2 hydrogen 1 2 3 1 hydrogen 1 2 3 1 hydrogen clear how many carbon carbon sigma 6 1 2 3 4 5 6 6 plus 2 8 9 10 11 12 13 14 so there are 14 sigma bonds if you are further elaborate out of 14 sigma bonds 6 are carbon carbon sigma and the rest are carbon hydrogen clear how many pi bonds are present only 2 number of pi bonds are 2 no need to mention here sigma how many sigma bonds between sp2 sp2 only 2 one sigma second sigma there are nothing what about this compound calculate sigma it will contain 2 hydrogen 1 1 1 1 am I right clear so 2 plus 2 4 5 6 7 8 9 10 11 12 13 14 it also contains 14 sigma how many pi 2 number of sigma between sp2 sp2 1 3 2 3 here it contains 3 see I have kept this same number of pi bonds but a different question the number of sigma bonds between sp2 sp2 varies right is it benzene I can write it like this also delocalization of pi electron right so how many hydrogen which each carbon will contain it is 3 degree 1 2 3 it will contain 1 hydrogen that is 1 hydrogen 1 1 1 1 1 that means there are 6 hydrogen atoms 6 sigma plus this 6 1 2 3 4 5 6 12 sigma so benzene have 12 sigma bonds out of 12 sigma carbon carbon sigma 6 plus carbon hydrogen sigma 6 how many pi bonds benzene have only 3 how many sigma bonds are present between sp2 sp2 because every carbon in benzene is sp2 hybridizing it is sp2 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 now calculate 1 2 3 4 5 and 6 is it clear if I will take example of naphthalene in previous lecture I have asked you whenever rings are fused together by 2 carbon atoms out of infinite rings only one ring will contain 3 pi bonds the rest rings will contain 2 pi bonds or I can mention it in naphthalene just like this clear 1 2 3 double bond single bond double bond double bond single bond double bond double bond single bond double bond here double bond single bond double bond double bond single bond double bond double bond single bond double bond right calculate sigma bonds can I start it from here it will contain 1 hydrogen 1 hydrogen 1 hydrogen 1 hydrogen Clear? Is it tetravalent? 1, 2, 3 and 4.
Yes, sir.
1, 2, 3 and 4. No hydrogen. No hydrogen. 1, 1, 1, 1. How many hydrogens are present? 1, 2, 3, 4, 5, 6, 7, 8. Now can start from this. 8 carbon hydrogen sigma are 8. Now carbon carbon sigma equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That means total are 19 sigma bonds. How many pi bond? 3 plus 2, 5. How many sigma between sp2 sp2? Can it? All carbons are still. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. They are 11. You got it? और ऐसे कभी कभार वेरी लेस कॉमन तो क्वेश्चन आते हैं, पूछते हैं कितने सिग्मा कितने पाई. क्लियर? तो आपको अब ये पता चला बेंजीन में, इन बेंजीन मॉलिक्यूल देयर आर हाउ मेनी सिग्मा बॉन्ड्स? 12. आउट ऑफ 12 सिग्मा बॉन्ड्स 6 are carbon carbon and 6 are carbon hydrogen. Clear? Now what about this? Is it benzene?
Yes, sir.
Clear? At every carbon I will add one more carbon. Now tell me how many sigma bonds are present? अगर फिर भी किसी को कंफ्यूजन होता है, देखो इसको ओपन चेन फॉर्मूला में देखो ना. क्लियर? जब तक आपको ढंग से प्रैक्टिस हो जाए, है ना. अब देखिए डबल बॉन्ड सिंगल बॉन्ड, डबल बॉन्ड सिंगल बॉन्ड, डबल बॉन्ड. कार्बन टेट्रावैलेंट है. 1, 2, 3 it has one methyl group and one methyl group is CH3. Am I right? At every carbon CH3 join it. CH3, 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 CH3. Right? This is the same compound. Now calculate sigma bonds. First of all, we will calculate carbon hydrogen sigma bond. 3. How many carbons are? 1, 2, 3, 4, 5, 6. 6 into 3. 18. 6 into 3. 18. Carbon hydrogen sigma are 18. Now calculate carbon carbon sigma. How many are present? 1. Start from this. 1, 2, 3, 4, 5 and 6. 7, 8, 9, 10, 11, 12. Clear? 12. Total sigma bonds are 30. You got it? This point. How many pi bonds are present? Only 3. How many sigma bonds between sp2 sp2? sp2 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 sp2. Why? Because in benzene each carbon is sp2 hybridization, and we have to mention this sigma only, not this sigma, because it is sp3. How many sigma? They are 6. कोई कंफ्यूजन तो नहीं रहा इसमें? क्लियर हो गया? ये नोट करो, मैं दूसरा ऐसा एग्जांपल दूंगा. नोट इट. इन एंथ्रासीन how many sigma bonds, pi bonds and sigma bonds between sp2 sp2 are present? Also mention carbon carbon sigma, carbon hydrogen sigma. जल्दी बता दो. CSF में कन्वर्ट कर लो. राइट? 6 कार्बन. काउंटर तुम सो रहे हो क्या? हाँ? बिल्कुल ऐसे ही है. सिंपल तरीका. अब देखिए पाई बॉन्ड. स्टार्ट द फर्स्ट पाई बॉन्ड फ्रॉम दिस कार्बन. डबल बॉन्ड सिंगल बॉन्ड, डबल बॉन्ड सिंगल बॉन्ड, डबल बॉन्ड, डबल बॉन्ड सिंगल बॉन्ड, डबल बॉन्ड सिंगल बॉन्ड, डबल बॉन्ड, डबल बॉन्ड सिंगल बॉन्ड, डबल बॉन्ड. Clear? Now we have double bond. We have double bond here. Clear? This carbon. This also contains double bond. It will contain double bond, single bond, double bond. Clear? So this carbon will, it is 3 degree. It will contain one hydrogen atom. 1 2 3 1 hydrogen atom. Carbon structure valency is 1 2 3 1 hydrogen. 1 2 3 1 hydrogen. 1 2 3 4 1 hydrogen. 1 2 3 1 hydrogen. Go to this curve. It is 1 2 3 4 no. 1 2 3 1 hydrogen. 1 2 3 1 hydrogen. 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 And hydrogen. Clear? How many carbon, hydrogen, sigma are present? Count that. First of all, how many carbon, hydrogen, sigma are present? Start from this, right? 1 2 3 4 5 6 7 8 9 10. How many carbon, carbon, sigma are present? Start from this. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Clear? Clear? They are 16. Total 26. चेक कर लो दोबारा, इसमें कोई शक नहीं. ये कितने हैं हाइड्रोजन, कितने हैं 10. ये गिनो यहाँ से. एक देखो, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 और clear? They are 16. Now, how many pi bonds are present? Mention the number of pi bonds. 7. 3 plus 2 plus 2. Right? First ring contains 3 pi bonds, rest contain 2. 3 plus 2 plus 2. Pi bonds are 7. How many sigma bonds are present between sp2 sp2? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Am I right? Total number of sigma bonds between sp2 sp2 are 16. So we will conclude from here and tomorrow inshallah.